Welcome to this video on two-variable linear inequalities. We're going to jump right in and take a look at solving linear inequalities. Okay, why would I use this? My favorite restaurant, the White House, has only 15 eggs until more are delivered. An order of scrambled eggs requires 2 eggs in scrambled eggs, and an order of omelets requires 3 eggs in that dish. And so those are our restrictions, or how much each one does. Our restriction is 15 eggs. What are the possible combinations of orders? And if we let x represent, I'm going to go through this fast, but if we let x represent the scrambled eggs and y represent the omelets, eventually we get to this pink shaded area that represents all the possible combinations. And just as an example, if you take a look at 1, 3, well, 1, 3 would be one set of scrambled eggs, or one order of scrambled eggs, which would be 2 eggs total, plus 3 orders of omelets, and that was 3 eggs per order, so that's 3 times 3 or 9. Well, that is in fact 11 eggs, and that meets the constraint that we had of less than or equal to 15 eggs. So that's the kind of thing we're talking about. And you know what? All these other individual points here meet that same criteria, so we could dot those in. But one way we represent this is we just, instead of dotting everything in, we just kind of shade that whole zone in, and that tells us that those are all the possible solutions. Notice that I didn't go over here into this quadrant over here, the second quadrant, because these are some, well, the y values are positive, but the x values are negative, and you're not going to have negative orders of scrambled eggs. Over here you'd have negative of both, and you're not going to have that, and over here you just have the negative for omelets. So we exclude those in saying that, hey, you know what, we're not going to include that because you're simply not, it doesn't match the context of this problem. All right, so here's our overall methodology. We have a linear inequality that we're starting with here, and it's not that easy to graph, so we're going to convert it first of all into slope intercept form. Intercept form, sometimes known as y-intercept form to some people, because you get it into a y equals kind of format. And here's how we're going to do it. We've got it, I've rewritten it down here. We're going to add 6x to both sides. We get negative 2y is greater than 6x minus 4. We're going to divide by negative 2, and that means divide the entire thing by negative 2. That reduces this to 1, so I get y. And then when we multiply or divide by a negative, it's going to flip our linear inequality symbol. Okay, so now I don't have a greater than, I have a less than. This becomes, or reduces to, negative 3x, and this is plus 2. All right, and so now I've got it converted. See, I stuck it in my little meat grinder here. Popped out the y is less than negative 3x plus 2. So I've got it in the form that I can graph from. So step 2, graph it. And I got to make, well, let's see, let me go ahead and put some points on here. I start at positive 2 because that was the y-intercept. And then I'm going to use the slope over here, which was negative 3. I'm going to convert that to negative 3 over 1. This was, so this was my y-intercept. Again, well, they might call it y-intercept form. And this is my slope. So I start with the y-intercept, plot that point, and I use my slope, which says go down 3, 1, 2, 3, and over 1. Down 3 and over 1. Down 3 and over 1. Down 3 and over 1. I can also go up 3, but then I'd have to go left 1. Up 3 and left 1. Now, the next decision I need to make is, am I going to go with a dotted line? Probably should have underlined that with a dotted line, or a solid line. All right, and the way you decide is the linear inequality symbol. If it's a less than or a greater than symbol, we're going to do a dotted line. And if it's a less than or equal to, or greater than or equal to, we're going to do a solid line. All right, and I'll explain that in a second. So on this particular one, we're doing a dotted line. Dotted line, and all right. And then we're ready to start shading. Remember a minute ago we had one side shaded. All right, so I need to recreate that. I'm going to roughly, whoops, I had a dotted line. I need to get the dotted line on there. I'm going to roughly put that on here. I just wanted to kind of build as we're going along. And so we're going to test a point, and I'm going to test 0, 0, because 0, 0 is typically very easy to test in your equation. That's x and y. And I'm going to test that point I'm going to jump back up here to the, no, I'm going to over to the one that we converted into a y-intercept form and test it in this. So I put 0 in for y is less than, well, negative 3 times 0 plus 2. So that simplifies to 0 is less than, well, that's 0 plus 2, or just 2. Is 0 really less than 2? Well, yes, it is. Okay, that means that 0, 0 is part of my solution set. And if I tested other points on this side of this line, they would also be true. If I tested a point over here, it would be false. And so what I'm going to do is I'm going to shade this on the side where I tested true. Okay, so this is going to be my shading, and that basically represents the solution to this two-variable linear inequality. All right, let's take a look at some other examples kind of following that same method. And at any time, if you feel comfortable, you can pause the video, try the problem yourself, and then see if the answer is correct that you've gotten. All right, so for step one, I said, well, is it in slope-intercept form? This one is not. So I'm going to quickly convert it into slope-intercept form. I got y less than negative 3x plus 8. Oh, I did a subtraction. Does that mean I flipped the symbol? No. It's when you divide or multiply by a negative that you flip that symbol. Now I've got it in the right format. So I'm going to go over here and start with my y-intercept. So I got plus 8. I put that point on there. Then I use this slope. And it's, whoops, down 3 over 1, same as the last one. Down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. All right, and then I'm going to check to see if I'm going to do a dotted or a solid line. And because this is just a less than symbol, not or equal to, I'm going to do a dotted line. And what that dotted line represents is this is a boundary, but because it has to be less than that, I'm not actually going to include those points. So the dotted line says, hey, here's a boundary, but don't include the points on this. All right, and now I'm going to test something. And 0, 0, I want you to notice that it is not on the line, so it's okay to test. I didn't mention it earlier, but if 0, 0 is actually on the line, then don't test that point because that's not going to tell you whether to shade on one side of the line or the other. All right, so it's not on the line, so I'm going to test it. I'm going to put it into this equation because this is where my line is. So 0 less than or equal to negative 3 times 0 plus 8. And here's one reason I like 0, 0 is because it's really easy. Negative 3 times 0 is 0. So I get 0 plus 8. So 0 is less than 8. Is that true? It is. Therefore, I'm going to shade on that side. If it was not true, I would shade on the other side. So this is where my solution set exists. All right. Take a look at the next one. Let's see, this is, I've got, well, it's a little bit worse than the last one. It's definitely not in slope-intercept form, so I need to start converting it to that. And I'm going to start by adding 2x to both sides. 2x to both sides. I get 4y is greater than, some people might write that as negative 12 plus 2x, but I'm going to write it as 2x minus 12. I'm kind of working towards that slope-intercept form. I'm going to divide by 4. Do I have to flip the symbol at this point? No, because it's only when you divide by or multiply by a negative, and I didn't. I divided by a positive. Okay, and this 2/4, of course, can be reduced, so that's 1/2 x minus 3. Now I have it in the format that I'm going to test in. I'm also going to graph it from it because it's so much easier to graph than it is from that other one. All right, I'm going to start again with my y-intercept. So I'm down here at negative 3, and then I've got a slope of 1/2, which means to go up 1 and over 2. All right, so up 1 over 2. I continue that pattern, and then while I'm doing this, you decide whether it's going to be a dotted or a solid line. Well, if it said or equal to here, I would do a solid line, but since it doesn't, I'm going to do a dotted line, which means that the actual solutions on the line are not really included in the solution, or the points on the line. And then I'm going to test a point, and oh, good thing 0, 0 is not on the line. If it was, I would have to pick a different point, but I'm going to test 0, 0. And I get 0 is greater than 1/2 times 0 is 0 minus 3, or 0 is greater than negative 3. Is that true? Yes, 0 is greater than -3. So since that's true, I'm going to shade on that side. If it were not true, then I would shade on the other side of this line. All right. And let's see. One more, and then I think it's time for you to do the you try section. All right, I'm going to subtract x from both sides. I'm working to get this into slope-intercept form. Hopefully they're seeing that pattern. Negative x plus 5, and then I've got oh, wait a minute, negative y, but I want it to be y. Well, this is like a -1 in front, so I'm going to divide by -1 on both sides, and that reduces that to 1, so it's just y. And I almost forgot to flip the symbol. When you multiply or divide by negative, you need to flip that inequality. Negative divided by negative is just a positive, so that's x over 1, or just plain x. And then positive 5 divided by -1 is -5. All right, so here's my inequality that I need to, linear inequality I need to graph. And I start at -5, and then I'm going up 1 over 1. So because the slope, which doesn't show there, is 1, and I can convert that to 1 over, whoops, 1 over 1, not 1 over 2. All right, 1 over 1. And then am I going to do a solid line or a dotted line? Well, this time I'm finally going to do a solid line, and that's because it has the or equal to portion of it. So that's telling me that the points that are on this line are actually solutions as well. And then I'm going to test something. Again, 0, 0 is available, so I'm going to test it. It means it's not on the line. So 0 in for y, 0 in for x, and simplify on both sides of this inequality, and I get 0 is greater than -5, and that is true. Think that through a little bit. And so this worked. If it didn't work, I would shade on this side, but it did work. So I'm going to shade on the other side, or the side with 0, 0 on it. Okay, and I could get a little bit neater and show that proper, but that's the answer. Oh, we got one more. Let's see what's different about this one. I'll kind of go quick here. Plus 5x to both sides. I need to get it in the y-intercept form. -2y greater than or equal to 5x minus 10. I'm going to divide by -2. A flag should be going off in your head. I just divided by a negative, so I'm going to flip that symbol. And this 5 over -2, well, that's just a -5/2 x. So that negative can go in the denominator, numerator. Typically we see it up in the numerator or out in front of the fraction. And then I've got negative divided by negative, so this is plus 5. And I'm ready to graph it. So I'm up here at 5, and I'm going down 5 and over 2, down 5 over 2, down 5 over 2, or up 5 and left 2. And it's a solid line, so I'm going to throw a solid line on there, and then I'm going to test 0, 0. Every time 0, 0 has worked out, does that mean it's always working out? No. Let's see if it happens this time. I think it does. 0 is less than or equal to, well, this is all just 0. That's why it's so nice to use this, and I got plus 5. Is 0 less than or equal to 5? Yes, it's true. Therefore, I'm going to shade on the 0, 0 side of this. Okay, and that shaded area represents the solution to my inequality. All right, this is the you try section, so I'm going to leave it with you. Again, your teacher has the answers to these, so finish these out, bring it to your teacher, see if you're doing it right. Go back and look at the video if you need to, and see if that helps you.